Welcome back to the presentation video about separation techniques, and we continue here with paper chromatography. Normally we would do a practical about this technique, as it makes it so much clearer, and you could try this at home. I'll explain as we go what to do. Paper chromatography, the word chromatography comes from the Greek, and chromato means color and graphy means to write, so it means to write with color. And this is a sort of a basic technique which was developed later into more an advanced technique, using the same method, but not necessarily for colored substances, but using colored substances, it becomes much more clear what happens here. Now, you can use this using a colored pen, filtstift in Dutch, we would say. Use black or brown or purple, then you see the clearest what happens. And you can take some paper. Actually, we would use chromatography paper in class, but you could use a coffee filter, or you can use some regular white paper and make a strip and draw your sample and draw a pencil line through the sample. And then you take a glass of water, and you make sure that your paper is in the water, but don't let the dot that you have drawn into the water. So the water needs to be underneath the water, and then leave it there for a while. And what you'll see is that the liquid, we call this the mobile phase, mobile because it moves. So the water will be sucked up by the paper, and the paper we call the stationary phase. And stationary because it does not move. Stationary means to stand still. So, and what it will happen is that the water will be absorbed by the the water will be absorbed by the paper. So the absorption to the stationary phase, we say here. And depending on which solvent you have and which paper you have, that could differ. So that's why the separation technique depends on the absorption to the stationary phase, but also how your sample will dissolve in the solvent, in the mobile phase. So what will happen here is that the ink will dissolve in the water and will be pulled up together with the water. And the one kind of ink, one color will stick more to the paper than the other, leaving a trail like you see here. And at one stage the water will not rise anymore, and then you can draw a pencil line there as well, and you leave your strip to dry, because we'll do some calculations with these measures afterwards. Now you can read in your book about this method, and on the next slide I've made a summary. And once again, if you have edition 1, you can find this method described in 1.4. If you have edition 2, in 1.6. This is a very boring slide. I'm very sorry about this. Normally at school on the board I make a drawing. Let's just go over what it says here. So the solubility, what is solubility? That is, how well does the substance dissolve to the solvent. What is absorption? Adsorption, not absorption, that's a difference. How well does the substance stick to the paper? Each substance travels at a different speed. The more soluble a substance is in the solvent, the further it will travel. The more the substance is attracted to this paper, the less further it will travel. You can use this for finding out how many substances are present in a mixture. You can use this for checking on the purity of a substance, separating out impurities, identifying the substance in a mixture by measuring how far it will travel. And there are some examples of how you can use this in your exam style questions, the end of chapter questions. So make sure to do these. If you're working with a substance that has no color, you could use a locating agent, and a locating agent can be sprayed on certain substances, for instance, used with amino acids, which you know from biology, and can make a colorless substance visible. Now, as I said, we're going to do some calculations, and in your book, if you go to the unit, and I'm going to grab it as well. Sorry, that's taking a little while. I wasn't prepared. You see in the extension part, figure 4, so 1.4.4 or 1.6.4 for you, and there they explain how the RF value is calculated. And the RF value is your retention value. So that's how far has the substance been dragged onto the paper, and that will always depend from your solvent and from your paper. So if you're using a chromatography in a lab, and we use it there with a method called HPLC, that's high pressure liquid chromatography, or GC, which is gas chromatography, they will always say which kind of stationary phase and which kind of mobile phase you're using. In any case, you need to measure how far the solvent has traveled from the baseline to the solvent front, and that is the distance moved by the solvent. So that goes below your in the lower part of your division, and in the upper part is measured how far the sample has gone. And in the example in your book, and perhaps I should have added this slide, you see that A travels 4 centimeters compared to the solvent front, which has traveled 6 centimeters. So then you would divide 4 divided by 6, and you get the RF value of 0.67. And this RF value for the same solvent and the same stationary phase is always the same. And then you can compare that to values that have been calibrated, have been determined in a lab. Okay, so I realized that chromatography is rather difficult, so study this properly in the book, and if there are any questions, please contact me via email, via Zoom. I'm here to help you. Another rather complicated method is distillation. You have 2 kinds of distillation, simple distillation and fractional distillation. And simple distillation is easiest to explain. That is used to separate 2 liquids or a solid from a liquid where you want to keep the liquids. And it's based on the difference in boiling point. So what happens is that you take your mixture and you heat it. Here, heated with a Bunsen burner, but actually in the labs where I've worked later on is always used a sort of a heating what we call a mantel, we say in Dutch, so a sort of a electrical heater, and you heat up the mixture in this round bottom flask, and at one stage the substance with the lower boiling point will start evaporating. And so first the one with the lower boiling point will evaporate out, going up into the fractionating column. This is to help the purification. And then here you can measure the temperature at the top. And then once it reaches top, it says cool down again, because remember the heat is here at the bottom, and it will become liquid again. And then here this condenser is used to cool down the substance again, and then it will drip into this flask, and then you can yeah, collect it here. This technique is used to make, for instance, distillates. So distillates are things like the Italian grappa or the Dutch Jenever or the English gin, where fruit gets fermented, or potatoes for vodka, or Jenever is made with wheat, tarwe, and so it gets fermented, and in fermentation alcohol is made, and it's mixed obviously with water as well, and then it gets heated and the alcohol is purified, so you get a more intense alcohol level. It also keeps better, and in that way, and some people like to drink that. The French have the French make something called eau de vie. It's all used in the same distilling kettle, the process with the distilling kettle. Now, fractional distillation is actually a super important method used a lot to make lots of products that you use. Any product made from oil is used with is made with fractional distillation, or let's say the oil is separated with fractional distillation. So oil, as you might know, is a mixture of all kind of carbon molecules, short ones and long ones, and these get separated to make, for instance, petrol for cars, or kerosene for aeroplanes, or diesel for also for cars, or for tractors, or for trains, but also oils to lubricate your bicycle, or bitumen for the road, or for on roofs, or to make chemicals, to make plastics. So for lots and lots of products that are nowadays important for us. And I'll not bore you more with my explanation. You can watch this video here to see a very interesting and illustrating video about fractional distillation. Let's just double check that it works. So indeed, 4-minute video to watch. So I'll see if I can mount this video in here. Okay, so here we come to the last slide, and if you have made a overview, it should look a bit like this. Of course, you can copy this, but by making it yourself, you will learn more about more. But you can use this overview to check. And I've also added here the Dutch words. So this is a good overview to keep also for next year if you do chemistry in the upper grades. I thank you for your attention, and please let me know if you've got any questions.